Okay, so in this video we're going to be looking at the inverse function. So basically the inverse function, it sounds a lot more complicated than it actually is. What an inverse function actually is the reverse of a original function, which is exactly what it is supposed to be. So let's look at an example. So let's say we have a function f of x is a function of x, and the function is 2 minus 5x. This is the original function, and this is a linear function. So in order to inverse this, like what this does to x, like what this f of x value depends on is what happens to x. So x is being multiplied by 5 or negative 5, and then it's being added to 2. So it's actually positive 2 minus 5 times x. That gives us our f of x value. So to inverse this function, we need to do the exact opposite. And the easiest way to do this is to swap x and y values. Variables. So let's say we have this example, and what I'm going to do first is put a y here instead of f of x, and then I'm going to swap it. After swapping it, now I'm going to solve for y. Basically, I'm going to get y alone. This is just some simple algebra, and that will give me my inverse function. So one of the first things I'm going to do is I'm adding 2 to this side, so I'm going to subtract 2 from both sides. And that'll give me x minus 2 equals negative 5y. So I have negative 5 being multiplied on this side, so I'll divide both sides by that. So now I'm left with y is equal to this, which if you apply the negative, it should be 2 minus x over 5. And this is your inverse function. So if f of x is equal to 2 minus 5x, our inverse, and this is how we notate inverse, is 2 minus x over 5. And yeah, the inverse is also a function. So that's how we do that. So let's look at another example. Let's look at a plot. Let's say we had one, two, three, four. That's negative 4. Let's say we had 1, 2, 3, 4. That's positive 4. Let's say we had 1, 2, 3, 4. 1, 2, 3, 4. So let's plot some points. Let's say we have a point here, 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 I have these points, and I ask you to graph the inverse function of this. And this is actually very straightforward. It might confuse you, but what you can do is let's draw an imaginary line. Let's say it's going and this imaginary line is basically y equals x. So now that we have this imaginary line, now I'm going to plot a mirror of everything, basically. So remember when I said we're going to swap the x and y coordinates? So you'll notice that, well, let me just put a notation that what I'm going to do in orange is our inverse. So right off the bat, if we have a, let me just use both. If we had this point, -3 comma 1, this will become -3, and same with all of them. So this will become right here, and that is basically a mirror of that. Same with this one. -2 comma 1 will become 1 comma -2. Same with this one. 1 comma -1 will become, -1 comma 1 will become 1 comma -1. You can see that it's a direct inverse. This one, we can just eyeball it and we know it goes here. And that's that. Like, let's look at this one. 4 comma -1. That becomes -1 comma 4. That's -1 comma 4. That's all the way up here. Same with, what else am I missing? Oh, this one. I have 0 comma 3. That becomes 3 comma 0. And our 1, 2, 3, 4, 5, 6 points have been plotted. 1, 2, 3, 4, 5, 6. And it's as simple as that. So let's do one more. And this one is going to actually be a function, a linear graph. Can't use that side. Let's do a proper function. Okay. Those are just intercept points. I'm gonna try to draw a line here. And this is going to be y So you might be wondering, maybe I could find the slope and the intercepts and create the full function dy equals mx plus b function, swap them, and then write it out again, x minus b over m equals y. You could get the inverse function like that and then plot it out. Or, because that would, you would also have to like redo this or move this around to become into this format. But it's too much work. I know right now that we have the intercepts here. For our g of x function, we have 0, comma. Let me just write it here. Our y intercept is equal to 0, comma 4, and our x intercept is equal to I want to say that's that should be 5. I'm a little bit off here, but it's okay. Let's put that as 6. Our x-intercept is 5, comma 0. So when we want to do the inverse, let's swap these around. Our y-intercept will become, we're going to swap the 2, and that'll give us that will give me this point will be mapped to the inverse. So 0, comma. Sorry, I don't know. I must be half asleep right now. I'm just confusing myself. This is a 3. So our new value will be mapped here at 3, comma 0. And that is confusing. So our y-intercept will go from, our y-intercept, which was 0, comma 3, will invert and become 3, comma 0. And that'll become our new x-intercept. And our x-intercept, which was 5, comma 0, will invert and become our y-intercept. Well, this is going to be 0, comma 5. 0, comma 5, that's up here. And that is my new line. So this is y equals g of inverted of x. Wow, I actually confused myself there. But happens to the best of us. Just gotta retrace your work backwards. And yeah, that is just taking it one step at a time. And yeah, that's all for the inverse function. I'll see you in the next video on to something maybe more confusing.